Hello, and welcome to this presentation, Understanding S-Parameters. In this short presentation, we'll explain what S-parameters are and how they're used to measure networks. Let's start by explaining what we mean by a network. In the radio frequency world, a network is a device that has one or more ports, with each port being able to pass, absorb, and/or reflect radio frequency energy. An example of a one-port network would be an antenna or a dummy load. Common two-port networks include things like filters or amplifiers, and a three-port network could be a device like a directional coupler or mixer. One, two, and three-port networks are the most common, but networks with higher number of ports also exist. We can analyze these devices, or networks, by injecting RF energy into a given port and measuring the level of RF energy that appears both at that same port, that is, the reflected power, and in the case of multi-port devices, at the other ports. Except in some very special cases, usually only one signal is injected into one port at one time. And in most cases, our network will exhibit frequency-specific behavior, so measurements are normally made over a range of frequencies. In most cases, networks are analyzed using instruments called network analyzers. The most common way of representing these quantities is something called S-parameters. The S stands for scattering, since we're measuring how much RF is scattered back from and out of the various ports. S-parameters are named using the capital letter S followed by a pair of subscripts. The first subscript is the port where the energy emerges, and the second subscript is the port where the energy enters. For example, if we measure the amount of power passing through a two-port network, this quantity would be referred to as S21. The amount of power reflected back on port 1 would be referred to as S11. Let's give a more complete definition of S-parameters for a two-port network. A two-port network will have four S-parameters: S11, S21, S12, and S22. S11 is the amount of incident power that's reflected by the input or forward port. S21 is the amount of power that's passed from the forward to the reverse port, and S12 is the amount of power passed in the opposite direction. The last S-parameter, S22, is the power reflected from the reverse port. These S values can be defined as ratios of the power seen at each port. There are a few other useful things to know about S-parameters. First, S-parameters are sometimes represented in the form of square n by n matrices, where n is the number of ports. For example, 1 port, 2 ports, and 3 ports. It's also important to remember that S-parameters are complex values consisting of both a magnitude and a phase. The reflection coefficients, such as S11 and S22, are often plotted on a special graph called a Smith chart. And one of the main advantages of using S-parameters is that S-parameters of individual devices can be cascaded together to predict the overall performance of a system. Although S-parameters are almost universally known among RF engineers, there are also more common or conversational terms for some S-parameters. The reflection coefficients S11 and S22 describe the impedance match for input and output. This is usually quantified in terms of return loss or voltage standing wave ratio. Please see the presentation Understanding Viswar and Return Loss if you'd like to learn more about these measurements. For transmission coefficients, S21 corresponds to the amount of gain, or loss, between the input and output ports. S12 is a measure of reverse isolation, or how much power is flowing the wrong way through a device. For example, an amplifier should have gain in the forward direction, that is a positive value for S21, but ideally zero power flowing back from the amplifier output to the amplifier input. Let's end with a quick summary of what we've learned. A network is a device with one or more ports, and each of these ports can reflect, pass, or absorb radio frequency energy. We measure networks by injecting power into one of these ports and simultaneously measuring the power that appears at that port and at the other ports. The standard way of representing these measurements uses something called S-parameters, which are given in the form of S sub xy, where x is the output port and y is the input port. Keep in mind that S-parameters are complex values, which typically change over frequency. Although the use of S-parameters is very widespread in the industry, many 1- and 2-port S-parameters also have more common names like gain or return loss. And finally, it should come as no surprise that the instrument most commonly used to measure S-parameters and analyze networks is called a network analyzer. This concludes our presentation on understanding S-parameters. Thanks for watching.